Hi everyone, welcome to the 10th session of the Humane Conversations. My name is Anthi Solaki and I'm a postdoctoral researcher in the research priority area Humane AI, and I will be the host of the session. So for those of you who are not familiar with us, Humane Conversations is a webinar. So it brings together researchers who do research on or about AI, and it provides an interdisciplinary forum for discussion and brainstorming on these topics. It is part of the activities of the research priority area Humane AI, whose goal is to study the societal consequences from the rapid development of AI. The recordings of our previous sessions are available online, so if you're interested in them, then please check our website. And now on the format of this session, so first our guests for today will give short presentations on their ongoing projects. Then I will kickstart the conversation by raising some questions. And then I will give the floor to you, the audience, to ask any questions you may have by raising your hand, unmuting yourself, or by just typing in the chat. So without further ado, warm welcome to our guests for today, to Katrin Schulz, Assistant Professor in Logic in the Department of Philosophy of the University of Amsterdam, who brings expertise in philosophy, linguistics, cognitive science, AI, among others, and to Robert van Rooij, the director of the Institute for Logic, Language and Computation, who brings expertise from philosophical logic, philosophy of language, cognitive science, formal semantics and pragmatics, again, among many others. And they will now introduce us to the very interesting topic for today, namely stereotypes in language and computational language models. So Katrin and Robert, welcome, and the floor is now yours.
Thank you.
Okay, thank you, Anthi. So we're first going to say something about our projects and how it came to that. So I will first start, and then Katrin, and then me again, and then Katrin. So we started actually with looking at the meaning of generic sentences. Generic sentences are sentences like dogs bark, tigers are striped, pit bulls are dangerous, but also habitual sentences like John drinks coffee before he goes to work, right? And these sentences, well, they express generalizations, but the interesting thing is that, well, they allow for exceptions, and they allow for exceptions to different degrees. So for instance, dogs bark, they don't allow for many exceptions, but ticks carry the Lyme disease, or pit bulls are dangerous, right? So pit bulls attack, but they don't normally attack, but still the generic sentence is supposed to be good. And then the challenge that we first had is to come up with the meaning or the correct use conditions of these kind of sentences. And the idea was they express generalizations, and the idea was, how we learn generalizations, or how maybe even animals learn generalizations, is behind the meaning or use conditions of these generic sentences as well. And then the idea is that not only frequency counts, but also how distinctive it is, for instance, for dogs to bark, right? And how much impact, well, for instance, pit bulls are dangerous, how much impact a bite of a pit bull has on us. So these are at least two things that we take to be important. And this is a theory that Katrin and I first developed. And one of the main goals of my project is to empirically investigate this by using experiments. Katrin?
Yeah, so the core of our theories for generic senses are measures for how strongly we endorse certain generic senses. And these measures, as Robert just explained, are linked to psychological theories for how strongly we associate certain groups with certain properties. So for instance, our theory says that we accept a generic like dog barks if the circumstances are such that we would learn to associate dogs with barking. And this is something, so this is a part of the theory that Robert also wants to test in this project, but recently we also gave a causal interpretation for these measures that we came up with. So basically what we are proposing now is this. We communicate with generic senses and similar expressions causal or essentially properties of certain groups, individuals or objects. But as causality is not something that we can directly see, it's not something that we can directly observe, the truth makers of these statements, so that the conditions that we consider have to be realized in order for the senses to be true or acceptable, these are the conditions that make us believe that the causal connection, the essential property is there. And these conditions are captured by our measures. So generics are not just about accidental frequencies that we observe, they are about essential properties. When we say something like Dutchman bike or dogs bark, we are expressing beliefs about inherent abilities of these groups. And that is what allows these generalizations to ground predictions for future behavior. But it's also what makes generics or the stereotypes that these senses sometimes express so dangerous. A generic like boys don't cry is not just a summary of past observations. It expresses a belief about essential properties of boys. If you cry, you're not a boy.
Yeah, so it seems that, okay, this is about generic sentences. What's the relation with AI? Well, modern computational models like BERT or GPT are supposed to have a lot of implicit knowledge of our language, right? And that includes not only, well, that includes also at least the implicit generalizations we have. And the interesting thing is that the way these language models are learned, right? So the method that's used here, the deep learning, is actually very similar to the psychological theories of learning that our theory was based on. So what we want to do now is to, or one of the things that I want to do in my project is to see what type of generalizations we accept, not just by looking at experimental work, but looking at what these types of language models, what type of generalizations we can find in these language models. And why is that interesting? Well, that's interesting because these language models are supposed to learn the language from huge amount of explicit language used by people. So it indirectly expresses what our implicit beliefs are as well. Okay, so that's implicit beliefs. But the interesting thing is that there's also, in these language models, there's also an explicit, an explicit way that generic sentences or explicit stereotypes are used. And that is, if you look at your search engine in your private home, you sometimes ask a question, and many of those questions use very explicit stereotypes, generics. For instance, to use an innocent example, why are Germans so punctual? Right. So, and what we use here is to use these auto completions, as it's called, and we've used the phrase "why are X so Y" to see, and then to look for Google, for instance, what are the most top associations between X and Y, to see what are the explicit stereotypes that people have. So that's one thing, and then. So we try to make a connection between the explicit stereotypes that people have with the implicit stereotypes that we found in this earlier work on these language models that have those implicit knowledge. Katrin?
Okay, now I have to connect this to my project. So, so Robert talked about, we already know that these language models pick up generalizations, and a lot of these generalizations we don't like. That's when we have this discussion about bias in AI. And at the moment, bias is discussed in AI as something that we generally need to get rid of. It's something that we don't want. AI systems shouldn't be biased. But actually, it's not that simple. Take a bias that plays a central role at the moment in the discussion, gender bias. Whether it's problematic that certain AI applications behave in a way that is biased with respect to gender depends a lot on the actual application you want to make of this AI technique. If you talk about a machine translation system that systematically translates pronouns referring to professors or directors or doctors as male, this is very unwanted behavior, and this is certainly something that we want to get rid of. But a system that breaks ties in grant applications with a bias for female candidates might actually be preferred. It might even be something that we consciously put into the system, because we could argue that bias sometimes needed to guarantee equity. Another example for the usefulness of biased AI systems comes from the NWO project I lead. In this project, we use the bias in computational language models, so the same kind of generalizations that these models learn that Robert just talked about, to answer a rather sociological question: how does media consumption influence our beliefs and behaviors? And the core idea here is this: we can take the bias the language model learns when trained on a particular media corpus as proxy for the bias that is in this corpus. So in other words, we can use the biased behavior of the AI system to measure properties of the underlying corpus it's trained on. And in this project, we employ such measures to study changes in the bias in media over time and compare them with changes in the implicit beliefs of consumers of these medias, and hopefully thereby we can establish causal links between both. That's in a nutshell what my project is about. Okay, this is our short presentation.
Yeah, so thanks a lot. That was very, very informative. Now I have a small question for Irina first, because is the recording still in progress?
Yes, it is.
Yeah, okay. To me it appears paused, but okay, that's not important. All right. Yeah. So I have some questions for you. Questions that are in principle applicable to both projects, but I will address one of you at a time. And if the other one has any follow-up remarks, then you're welcome to share those with us. So I'll start with Robert, and I will ask you, so what makes generics in particular special to you, for you to study? And like, what's the difference between the generics and just quantified sentences, where I could say most dogs bark or most pit bulls are aggressive?
Yeah, that's a good question. Well, I've been working in formal semantics for many years, and what I find particularly interesting for generics is that it's a challenge to account for the meaning. For most dogs bark, you just look at the amount of dogs that bark, and you say it's more than half, and then it's okay, something like that. For generics, it's much more challenging to come up with a good semantics that is good for all types of generic sentences. That's one thing. But second, it's also well, because of the relation with stereotypes, it's also much more important to have a good semantics of generic sentence to understand what's going on, and the relation with learning, right? That I find particularly interesting. And the other thing is, of course, that because we think there is a relation between, well, generics, implicit generalizations, and what you have in these language models. So that's yet another reason. So so in formal semantics, it's normally very far from natural language processing, but this is an area where we really can help each other, where findings from one area can contribute to other areas.
Right, I see. So from your empirical studies with human reasoners, you have found that the parameters that are important for humans when it comes to interpreting generics are different from the ones that play a role when interpreting quantified sentences then?
Well, it's much more difficult, yes. And for instance, it's clear that, right, ticks carry the Lyme disease. There it's not just the amount of ticks you look at, it's something else as well, and that's not the case for the normal quantifiers.
Okay. Yeah, thank you very much. Katrin, do you have any remarks on this?
Yeah, so maybe about the difference with quantified expressions. So there are clear differences. For instance, very interesting, I find this difference in acquisition. So we see, for instance, that young children, at least there's some evidence also debated, but there is evidence showing that generics expressions are learned earlier clearly earlier than quantified expressions in understanding as well as in production. And if you look simply look at the complexity of the expression, you also see cross-linguistically that generics have a very simple makeup, very simple syntactical and morphological makeup. So also there is some evidence that these expressions seem to be in an important way simpler and maybe even closer connected to our cognition. And the other thing is, so yes, so and in that sense, I agree completely with Robert that even though they are simpler, so it should be easier to account for them. The tools that we nowadays use in formal semantics and pragmatics to do our work, the normal formal semantic models that we use, they are really not well equipped to deal with these expressions. There's something, so they really seem to need a different kind of framework to account for. That makes it also very exciting to work on them. The other reason is something that, for me, that also makes them very interesting. It's something that also I think Robert already pointed out. So it's basically not so much, so primarily I'm not so much interested in these generic senses. I'm interested in how we come to generalize in general, so cognitively. And then we express these generalizations we express by using generic senses, for instance, in other constructions as well. And I find this process of generalization so interesting because in the end, this is the only tool we have when we make predictions. So any kind of predictions we make about the future, they're based on the generalizations they draw. So these generalizations are crucial, cognitively crucial in this respect. And that's also something that I find very interesting to look into.
Yeah, it's definitely very interesting. Yeah,
Robert wants to answer.
Yeah, so Katrin said that later on we thought that causality played a crucial role, and that's what we think. So one hypothesis that we have is that generics are learned so quickly and so easily is maybe because and if generics should be given a causal interpretation, or at least the people think that it should be given a causal interpretation, that suggests to me and to Katrin at least that we primarily think of the world in a causal way, and that fits very well with how that sometimes we can that generalizations have this causal background. And if we tend to have a causal view of the world, then it's very natural that generics are learned easier and used easier by children than quantified sentences.
Right. Thank you very much. And I think it's also important when it comes to causal inference in AI, right? So, yeah. Then my next question for Katrin has to do with the purpose of your project. So do you see the purpose as more descriptive? So you're interested in explaining how stereotypes emerge in human cognition and in computational models, or you also see a more prescriptive purpose in this? You want to propose ways to avoid stereotypical thinking, and if not in human cognition, then at least in computational modeling.
Okay. I think there might even be a difference between our projects. So when we talk about giving theories for generic senses, it's a completely descriptive project, and that there's agreement between us. In the project on bias that I do, in first instance, it's not a project about how it comes that there is bias in AI and how we could measure it and how we could mitigate and the anti-bias that is there. And so the primary use there of this bias in the AI system is to use it as a tool to understand something else better. We use it as a tool to measure bias that might be in the media that we consume, and thereby try to measure the influence this media consumption has on our behavior and beliefs. So that's basically a tool. Still, in order to shape this into a proper tool, we need to understand better what exactly the bias is that these AIs, these language, computational language systems pick up on, and how this is related to the bias that is actually in the corpus. So there's also a lot of work in this project. That's actually what we did in the first year on understanding better how we can measure this bias and whether we actually measure thereby the bias that is in the corpus that these language models are trained on. And this work certainly also can feed into this discussion and development of techniques to mitigate bias in AI systems. And so there I see a connection there. And then if you are working on this topic, bias in AI, so something that is needed at the moment, and you see also that it is picked up by many of AI researchers at the moment, is that we still struggle having a clear conceptual framework for bias and stereotypes in AI. And that makes the discussion quite confusing at some point. So it's not always clear that we all talk about the same thing when we say, okay, the system picks up some bias. And so I think I see also a role in my project for this conceptual work. So that's also something that we work on. And I think that also feeds then, you need this conceptual framework to be in place before you can have the normative debate about what do we actually want the system to do and where should be the limits? So what kind of bias is okay? What does it mean that bias is okay? And then specify, okay, this is not okay. How can we deal with that?
I see. Thank you very much. Robert, do you have any remarks on this?
Well, yeah, so I do agree with Katrin that in this sense, our projects are different. So my project is more descriptive than certainly almost only descriptive, but of course, right, descriptive projects also help to mitigate problems. So in that sense, it's needed. It's the first work that needs to be done before we can, well, so de-biasing, right? That you first have to know what the biases are before you can start to de-bias, I guess. So.
Yeah, sounds reasonable. The next question is for Robert. So it often seems to me that research on stereotypes depends on the researchers explicitly recognizing them as such. But the very nature of stereotype is that it is implicit in our cognition, so we cannot always identify it as such so as to facilitate this research in AI and bias. So I'm wondering if you have encountered such problems in performing your research, and if so, then how do you try to overcome this, your own implicit stereotypes? Yeah, so well, if you look at generic sentences, then it's mostly about explicit generic sentences. But if you look at these natural language models, what we try to do is two things, right? So we've tried to find these implicit biases that are learned via these modern machine learning techniques from huge amount of data, association between words, right? So, for instance, association between Germans and being punctual, or between, well, whatever. So that's one thing. But actually, what I found, well, I didn't, so I also agree with you that most of the stereotypes I thought were completely implicit. What I learned, at least so far, is that there's a huge amount of explicit stereotypes as well that you actually also can find via these modern methods, and in particular to these autocomplete methods, because if people try to look in their own room for asking questions, they, well, to my surprise at least, they use very explicit stereotypes, and this is also what you can find. And well, this is not something that we did, but apparently it is the case that a very good way of predicting who won the presidential election in which state in America, for instance, right, was how many times people used the N-word in that state in those states. So it's very explicit, although you think it might be implicit racism there. Actually, it's very much explicit. Okay. Yeah, that's a very surprising finding. Or maybe not so surprising. Depends how familiar one is with the situation. All right. Then my next question is for Katrin. I mean, unless Katrin also has some remarks on this.
Well, so for my project, it's a bit, I think, a bit more complicated, because we also have to measure at the same time stereotypes or biases in the beliefs of speakers. And in the test situation, there is a difference with respect to how explicit you are about the stereotypes, about the biases that you have in your beliefs. So it is a challenge. It would be preferable to have a measure there that measures implicitly, implicit biases, implicit stereotypes that you believe. And that's actually very problematic. So there are measures out there which are very well established. So like the IAT, the implicit association test, or the priming testing. However, these tests are known to be not very stable, particularly on the individual level. So if you retest people, you make slight changes to the context, it turns out that the results are actually not stable. So for us, this is actually a challenge. So one thing we tried to do in the last year was trying to come up with a different way to measure biased beliefs in speakers that might hopefully perform better, but it's really hard. For us, it's really an issue.
All right. Yeah, so the next question is actually bias from my own research interests. So it has to do with bias in AI and bias in humans. And this is because when it comes to humans, we know from behavioral literature that we often rely on cognitive shortcuts that are often justifiable if you consider our limited resources or limited time. And in fact, these shortcuts are often correct. So it's not the case that they are necessarily wrong. So I have in mind here the vast literature on the dual process theories of reasoning of Tversky, Kahneman, Stanowitz, Evans, and others. So, for example, I can think of many occasions where when accepting the generic birds fly and not accounting, say, for penguins, is much more efficient than just listing all the relevant exceptions that may apply in that case. So this makes me wonder, do you think there are reasons why we might want computational models to actually inherit such features of human cognition, these system one features, to make our interaction with AI applications more and more efficient or more realistic? You think of chatbots or of virtual assistants, or you think we should just try to abolish them altogether just to achieve a normatively correct behavior, so to hold them to a higher standard than we hold humans? I think this might be also connected with your point about cases of that we may not want to eliminate bias because there is an underlying reason why we want that.
Yeah. So I think it really depends on the application. It really depends on what you want the system to do. And this is something I think that needs more attention also in AI. We have to be careful that we design systems for particular applications and what standards come with that. So even the notion, the very notion of bias is context dependence in this respect. A bias, I like the definition of bias where you say bias is a systematic deviation from a norm. But then the question is what the norm is, and what the norm is can very much depend on what a particular context of application is. There are situations where we want to have, I gave an example, where we want to have biased behavior in certain senses because we want to promote equity. And there are situations where this is, so we have a prescriptive norm where this bias, this deviation from this prescriptive norm is just simply unacceptable. And we have to be aware of that. So interesting, I think, is the question. So this is about these very explicit biases that we normally discuss. So like gender, and then there are clear instances where you don't want it, and there are instances where you want it, and it's clear. But so I think what also shows up in your question is, okay, let's not talk about stereotypes or biases in this particular framework where we really know that we don't want it, but more generally, the process of generalization. Huh? Is there something particular about the process of generalization in human cognition that makes it particularly efficient? So this shortcut mechanism, for instance, that we also want to implement into certain applications because it means that these applications become, in some sense, more effective. And for instance, and yeah, I can imagine that this is the case. But I think we also need to understand first better what exactly this cognitive mechanism is that we humans use here. Let me stop here. Let me think a bit more about this, and maybe Robert can give his 5 cents on this.
Yeah, let me say that our theory of generics is actually explicitly motivated by these theories of Tversky and Kahneman, for instance, right? So these short, for instance, right? So I mentioned earlier that impact matters, right? That distinctiveness matters, so of a feature for a particular type of person or animal or whatever, and that causality matters. And these are all very closely related to these heuristics that Tversky and Kahneman came up with. And so I think that because humans use these shortcuts, these generalizations are there. And I also think that it's reasonable, and only reasonable because we almost have to use these shortcuts. Or one of those shortcuts that we use maybe is that we have to have a causal model of the world, because otherwise it's just too complicated to understand. So so that's also why we try to understand as much as possible into a causal way, and maybe more than actually is warranted. Whether these language models should have the same thing, yeah, I agree with Katrin. It depends on for chatbots, as you mentioned. Well, it's probably very good if you really have a natural conversation with these chat boxes. Well, they should behave in a very similar way, and their cognitive makeup should be not too dissimilar from our cognitive makeup. Because then we understand each other better. So yes, then it should be the same, but maybe for natural language translation, for instance, right? It should not be that way, because maybe it makes mistakes where we don't want it. So yeah, it depends on the use that you make of this AI technique.
So what I was looking for, I wanted to think about a bit more, because there was something that was not clear for me. So maybe I think what I struggle with is in the formulation of your question, and also in the formulation that Robert gave just now, there was immediately this conclusion that these techniques, these shortcuts, they are more effective in some sense. And for me, it's not always that clear yet in what sense they are actually more effective. So what does this exactly mean, and how can we measure that? For instance, something related, confirmation bias. So we all know that we have confirmation bias, but it's actually not that easy to understand why we have this bias and in what sense this makes us function better. And I think this would be good to understand that before we look into implementing this in AI systems as well.
Yes, yeah, indeed, I see your point. But I think that at least one case where we can say that they're better has to do with the limitations in our resources. For example, in a situation where one has to decide not as a matter of, not in the way of a logician, let's say, not by sketching a derivation, but yeah, fast, frugal heuristic might be necessary in certain situations. And
interesting. It's interestingly. So we did some Oscar van der Waal, who's a PhD student in this NWO project. He does research on how bias develops during training in language models. He tested one particular, and there it seems so some data that he got in series experiments that he did also pointed to the fact that the model first employed like these shortcuts with very, very crude biases, very crude gender biases when the model still was in a process of learning gender. And then later in the training, it got more advanced, more sophisticated, and gender was represented in a clearer way. But at the beginning, it also seemed that it had exactly that. It has to be efficient. It needs to make this decision right now based on very little training data it has seen. And then it does also like these very crude shortcuts, gender biases.
Okay, that's an interesting analogy. All right, I think now we can move to the questions from the audience. And I think there is already one, if I'm not mistaken.
Yes, there is one in the Q&A chat.
Yeah, by Peter. Peter, you want to mute yourself and ask it, or maybe I should ask it? Okay, maybe I can.
Oh, it's now okay. Thank the two of you for your interesting presentation, but I have a fundamental problem before I'm able to understand what you actually are aiming for, and it has to do with the concept language model. And there are several things I can imagine there. If I'm old-fashioned, I'm thinking a nice semantical theory like Robert used to produce 20, 30 years ago. I can also think in terms of a well-trained neural network. And I can also imagine that you have something like a big matrix of all coincidence correlations between phrases and terms and things like that. And in all cases, the problem arises that if, this is particular for Katrin, if you want to compare the bias present in humans against the bias in a system, how do you model the system as a preliminary step in order to be capable of even inventing measures enabling you to measure this bias as present in the system? So can you measure it in case the system is a trained neural network? I can imagine you can do it if you have a big correlation matrix, but what's your take at this?
Thank you for your question. So there are methods, there are different methods to measure this. So actually, when we talk about language models, we talk about these computational language models, these neural systems. And there are different ways to do that. So we mostly look at two ways to measure bias here. So either you measure it, so if you look at the old system, so if you look at static language models, static word embeddings, you can measure it looking at these vector representations and look at how strongly different vector representations for different words are associated. And actually, these measures are not so different from the measures that are used in psychology when we talk about something like the implicit association test. So that's one thing that you can do. And then when you look at these more advanced language models, so contextual language models, what you can do, and that's also what we do, we look at downstream behavior. So we look at the behavior that language model then in the end shows. So for instance, this is also what Robert talked about. How would this language model fill up certain prompts? And can you see there? So for instance, you let it fill in, very simplified, you let it fill in a pronoun. Which pronoun does it choose? Things like this. And there you can also measure bias. Does this answer your question, Peter?
More or less. Can you use language models in such a way that it simply starts generating language according to the model?
Yes, you can do things like this.
So, and then you can observe it and subject it more or less to the same test as you would subject the human speakers to. Yeah,
something very similar to that. Yeah.
So for instance, what we did in our project was to ask use the prompt, why are X so Y, right? Why are X's so Y? And then just look at the language model, right? So it's trained millions of documents, I don't know, and then to see what are the associations that these implicit, that the language model has. So there's implicit knowledge between X and Y's, and then just look at the first, for each X, look at the first 10 Y's or whatever, right? So. So this is a very simple way, very crude way, but actually it gives very interesting results already.
And do you have any hope you could do it on an old-style theoretical language model?
Well, in terms of
grammar.
Well, we are not doing that because this is, yeah, I don't know whether there's any hope for that. I mean, nobody.
But I mean, but if you really look at these formal grammars, I mean, that's exactly the point. Is you would not expect them to be biased in this way. The problem with these computational language models is that, by the way we train them for more than just extracting this grammar information or this lexical information. And that's why it gets to pick up these biases. So I wouldn't expect there to be bias in these very, very traditional grammar models that we worked with, I don't know, or Robert worked with 30 years ago.
Well,
thanks a lot.
Yeah.
Thanks a lot. I'll leave it to others then.
Okay.
Stay there. I think we have a question from Tobias. Tobias, do you want to ask it yourself?
I can do. Sorry, I will not turn on my camera because I'm going to be on YouTube again then. Try to avoid in my life. But you have to, unfortunately.
Yes.
So I've got two questions. Actually, I also want to say that I find language modeling very confusing. So it took me a long time to understand because I also learned something else in my past life about it. And my questions are actually more about methods. So Katrin, maybe to you first. I think you briefly mentioned in your presentation that you, which is great, you basically use the kind of bias in language model to understand the difference that people generate over time by being exposed to media. Is that correct to say? So
yeah, in the end, this is what we hope to come out of that. Yes.
Yeah. So how do you measure the difference between biases, so to say? So let's say you take the language model on day X, on time point T1, and then you measure it again on time point T2. What's the difference between T1 and T2, if you see what I mean? So
yeah, so you have these bias measures that you can apply to these language models, right? And so you can really quantitatively measure this bias. So the bias, it might have a stronger or lesser strong bias with respect to gender, for instance. So that you can measure. And then the idea is that you train language models over time, so on different corpora. So that's basically fine-tuning. And then this fine-tuning could affect the biases we then get by applying these bias measure methods to these language models.
Okay, but don't you need then, if you want to say something like, so whatever, the media influenced my relationship on gender, right? Don't you need to then some media stories on gender that has happened at the same time in a way, or you see what I mean? So how do you bring these two together?
Now, so I'm not sure that I understand the question. So you have the corpus of the media that you consumed. I don't know. So then for certain months in sequence, and then you do fine training with this corpus each month, and then you measure the bias in the model that is fine tuned on this training corpus, and then you relate it to the bias that you measure at the same moments in time with the consumers of these corpora. So what you will need to link is you need to have the link between, so that's the main challenge here. So you need to have the link between the consumer and the corpus. You need to know what your participants actually read in order to make this work. That's the main challenge.
Okay, so you make the language model on each of these corpora that these consumers read. That's the idea, right? Yes,
that's the idea. And then you need to have we cannot really do this on individual level, so you need to classify people. But you, for instance, can classify people with respect to their political interests and then classify corpus based on that. And that way you can make a connection here.
Interesting. Great idea. Sorry. Robert?
Yeah, so the ideal way of doing this is, of course, to first look at people, say what are the implicit biases that they have, or the biases that they have, then to control what these people read, right? Yeah. So what is their input, and then see also what are the biases in that input, right? And then after time, see whether that changed the implicit biases of those people. Now, of course, right, there are many things that you would like to control, and it's very hard to control. But
that's not possible.
That's at least the ideal way.
Yeah.
But yeah.
But also a problem is if you really do it on this individual level, is that you don't. So the question is whether you get corpora that are big enough to have these effects when you do the fine tuning on the language models.
Yeah.
So that's even if you would be able to really trace the use of individuals in this respect.
I mean, maybe the good thing is, well, we have a contact with a company that actually allows people people allow this company to keep a record on what they are reading online.
Yeah, but then still you have this. Then you have the problem that you have very small corpora. So the question is whether they are big enough to have the fine tuning. Yeah,
that's absolutely the case. But so there are many challenges. But
but it's a great idea. I like that idea. I always thought that it's a good, useful approach, not just to use bias as a kind of no, but also actually checking on what culture actually might be at this moment in time. If I understand that correctly. Yeah. Sorry, I quickly asked also Robert. So this autocomplete is a great idea too. So, but are you not a bit worried that if you ask the Dutch person, or the person in the Netherlands, I should rather say, why are Germans so ... They answer differently, and also if you use that in English rather than in Dutch, then if you ask the German person, why are Germans so ... So how do you do this kind of intercultural complications in this?
Well, we think of this as an interesting thing rather than a problem. Okay. Because what you so for instance, you can actually look at. So, for instance, you have Google Germany or whatever, right? So you can ask this thing in for the German language, for the English language, and then apparently you can also some of these search companies even tell you where so to locate, so to have restrictions on the location on where they are searching this. So actually, this is actually a great tool to do this more sociological research, right? Now, I'm not a social scientist, but so I think this is actually, a great opportunity to use the internet and to use these autocomplete ideas to do research on how people think in different communities.
Yeah. Great, thank you very much. That's it for me. Thank you.
Thank you for the questions.
Yeah.
Thank you for the answer.
Follow-up. I have a follow-up on this. Thinking about the autocomplete. So I think most search engines and at least the established online media have some sort of filtering. So it's not that if you will ask why are Germans so, and then something very offensive, that it will appear. It might be that people look for that, but it won't necessarily appear because of the filtering. So how do you make sure that you then get a realistic picture of the online world? Because it can be worse than we think sometimes.
Very good question. Actually, a PhD student, Alina Leidinger, was just looking at this in a very recent research. What we do, or what she does, I should say, is to look at different types of search machines. So, for instance, well, some of the search machines are very rude on what they accept and what they don't accept. Some are accept almost everything, and some are very more sophisticated. And of course, Google is one of those more sophisticated. And then you see, for instance, for Jews, only one thing, and it's very positive, right? Or these kind of things. So, so yes, but in general, so this is of course typically the case for, let's say, race and religion. But descriptively speaking, right, we want to know what are the generalizations that we accept. And that's and this is also something that is typically not done in this natural language processing research. We just look at all these types of nouns. So for y are x or y, so for all types of x's. So not only the ones that all this literature on racism and so on in NLP or in bias in NLP is concentrating on. We're looking at it in a much more broader context, and that's actually so that is interesting. The other thing that is then interesting is that different types of search engines have a different policy on what they allow for and not. And for instance, one of the findings was that the NLP researchers are very much concentrating on bias so on gender bias, I should say, while let's say Google and some other search engines, they are not so much worried about gender bias. They are more about, they are blocking certain search results for racism and religion particularly. So that was also interesting.
Okay. Interesting. So then maybe we can take one last question from Dean. Dean, do you want to ask it yourself? Or maybe.
Oh, can you hear me now?
Yeah.
Hi. Can you see the question in the chat in the Q&A? I can ask it again here. Yeah, so I was just wondering, Katrin, you mentioned it would be nice to have a general framework for thinking about bias. And then to that end, I was wondering whether, like, how do you quantify how biased an AI system is? I remember you have this work on causal powers, right? And that's very important to your account of generics. And I was thinking you could say something like an AI is biased to the extent to which a given protected trait like gender has causal power on the AI's output. Maybe, yeah, the work you already have on causal powers would give you a way to quantify bias, and that would help you achieve this goal of a general framework for thinking about bias.
I had just had a technical problem, so I have to let me check whether I understood. So it's basically about how we quantify the extent of bias that is in a system. Is this your question?
Yeah, if you have two different outputs and you want to say maybe not categorically one is biased and one is not biased, but measure to what extent each one is biased or whether one is better than another.
Yeah, so I haven't thought about this correlation to causal powers yet, but in principle, the measures that we use are quantitative measures. So they don't give the answer like this is biased, this is unbiased. You get quantities, and then you have to interpret them as a biased result. So in this respect, you can measure something like the strength as bias as well. A problem that we are struggling rather, what is a problem is, so there's a lot of discussion at the moment about different ways to measure bias that is in AI systems. And I already highlighted earlier in my reply to one of the questions that we have a conceptual problem that's not so clear what actually we mean when we talk about bias, and people might mean very different things. Another problem that we have very much is that these bias measures are not very well validated. So it's very difficult to say what exactly we are picking up on and how much this is really the bias that is in a system or is the bias of an underlying corpus. And I think a lot of research now needs to go into exactly that, validation of these methods. And there is a lot of research on validation procedures in psychology, and I think it would be very useful if now we try to kind of build on that and develop methods to validate these techniques also in AI, for instance, for the measure of bias.
Okay, so you're not planning on using your own work on causal powers anytime soon to do it. There are other measures already out there whose problems you want to investigate.
Yeah, so I have to, it's an interesting idea to make this link to causal powers, but I have to think more about this. At the moment, I'm more worried about the validation problem.
Yeah, that's a more fundamental problem. Yeah.
Right, thank you, Dean. So unless Robert has any remarks on this, no?
No.
Then I think we can thank Robert and Katrin again. Thank you very much for this nice conversation.
Thank you so much.